Okay, today's topic is mind-brain identity theory. And to give you a general idea of what's going to go on this evening, I'm going to say I'm going to give you a fair, balanced, and even-handed account of the theory and its opposition. So this is my sort of neutral explanation of what I'm going to talk about. Talk about a perfectly sensible theory of the mind, where the mind comes from, a sort of very basic theory that is obviously true, at least in my opinion it's obviously true. And then I'm going to talk about 3 deeply stupid objections to that theory. Now there might be other objections to the theory out there, and obviously there'll be more to talk about than what I'm going to discuss here. But the objections given in the book seem to me to be deeply stupid. So what my plan for today is to talk about the theory and the evidence for it and try and explain it and what it means and what it's saying and why I think it's true. And then I'm going to talk about how people argue about it and sort of weirdnesses in the text. And then I'm going to talk about the objections. And I'm not talking about the objections just to set them up and knock them down. They're also discussing these objections is going to allow us to discuss important things about the notion of scientific proof and what a scientific theory is. Right? So I'm going to talk about 4 things. First is the definition of MBIT, mind-brain identity theory, what it says, what it exactly says, and what it doesn't say. Right? There's things that it doesn't say, and the name mind-brain identity theory kind of makes sense, but it's also kind of misleading. And I want you to remember that it's just a name. They could have called they could have called the theory George or Michael or the brain theory or the brain theory of mind. Right? The brain theory of mind would have been a good name for it. Or the causal theory of mind, or the material theory of mind. Right? Calling it mind-brain identity theory, okay, that's what most people call it, but don't get too hung up on the word identity in there because it's used in a very particular sense that I will explain in a few minutes. Now I'm going to talk about Schapper's objection. And I'm going to talk about what Schapper is saying. Oh no, I skipped a bit. I'm going to do 5 things. Before I do Schapper's objection, I should do arguments. That is, I want to talk about why I think mind-brain identity theory is correct, why every scientist who studies the mind thinks that mind-brain identity theory is great. In fact, they don't even think it's a theory. They don't think about it. They just accept it. It would be ridiculous, even, it's something that in science is so accepted that it would be considered ridiculous to talk about it. Then I'm going to talk about Schaffer's objection. And we're going to talk about what it means to say the mind is made by the brain, what that actually means. And this is going to, in my view, this turns out to be deeply confused about the notion of identity, that's assumed in sentences like the brain is the mind, or the mind is brain activity, the mind is brain activity, the morning star is planet Venus, the water is H2O. Now we have these sentences, we use the word is. Right? What does it actually mean to say that something is a particular thing? What does it mean to say that Borat is... You guys remember Borat? Right, it's, okay. That Borat is actually an actor called Sacha Baron Cohen. Then after this, we talked about those issues. It's cool, interesting philosophical issues. Sense and reference, identity, they're interesting philosophical issues. So I like talking about them, and I think it's important they come up here. And then the next is, well, Schaffer's objection to me, it seems to me to be weird and confused. The next one, the correlation objection, seems to be, well, weird and it's confused. It seems to be just sort of just dumb. An inability to face facts, or an inability to look at evidence, because it's the correlation objection. And the last one is just plain stupid. The falsifiability objection. It's an, I mean, I'm making a big deal out of just a remark, one sentence remark that Palmer just sort of throws out at the end of the discussion and drops. He just, throws it out there and then goes on and doesn't discuss it, and I'm going to discuss it. So maybe that, maybe that's a little unfair, maybe he meant something else, but he doesn't say something else, I'm just going to deal with what he says. And that's the falsifiability objection. And I think the falsifiability objection shows an inability to understand the basic nature of science, or falsifiability, or conceit. It's just a really deeply, deeply ignorant objection. And I'm kind of amazed that it shows up in a philosophy book. By the way, I want to emphasize, I still think that the Palmer book is an excellent introductory text. There's a lot of good stuff in there, and it's mostly very clearly written. He only gets a few things wrong. Well, he gets a lot wrong, but there's we can talk about it. It's not. He doesn't get so much wrong that I can't use the book. I just got an email from a publisher asking me, offering to send me a review copy of a textbook I used like 10 years ago. And I wrote back that I had the misfortune to use that textbook a few years ago, and it got so much wrong, it was just completely useless, pointless to assign the book as reading. So I said, it's a terrible book, and I wish you would stop publishing it. It won't do any good. They'll keep publishing it. They'll be ruining philosophy for people all over the country. So you guys are lucky to have me. I might be the only one out here teaching this subject right. Well, there's probably like one or two others. I can't be the only one. So I'm going to I used to have low self-esteem. Solved that problem. Now I'm delusional. It's more fun. So, right, so this is my idea of what I'm going to do today. And of course, as always, and as in any class taught by me or anyone else, I could be wrong. The instructor could be wrong. Any class that you're in, the instructor could be wrong about something. He could be wrong about lots of things. And you always have to, you have to go through and write down what he said to pass the exams and get the good grade. But you can always, it's in the back of your head. You sit back and think, do I agree with this? Does he make a good case? Does he make a good case? Does he provide evidence? Is his logic good? And so you should never really take what I say as definitive. You don't look at my conclusions and say, oh yeah, Dr. Young says this, and it's right. It's like, well, Dr. Young says this, and he backs it up with this, and this, and this, and this, and I'm going to think about whether this argument is good, or this evidence is right. Right? I want you to be thinking critically about my claims, and if you criticize me in your paper assignment or the exams, you add a little criticism, that can only help your grade. That, in this class, I hope you know me well enough to know that if you disagree with me in something you write, that won't ever be penalized. Right? The worst that can happen is that it doesn't affect your grade. After that, if I look and say, well, that's an interesting criticism, that's a good idea or a good thought, that's a good line of thing, or that at least shows you're thinking about it, I can give you more credit for that. So if I've done my job right, you're all saying, yeah, okay, yeah, I can do that. And if I've done my job wrong, you're all thinking, yeah, right. He's going to let me criticize him. So I told you guys a story in a math class, and an instructor gets angry with a group of students, starts yelling at them when they say they don't understand the text. What do you mean you don't understand the text? And like, why is he getting mad? Well, because he wrote that text. And instead of doing what he should have done, which is to say, I wrote it badly and it didn't work, and these students need extra help because I didn't make myself clear, he's like, why are you insulting me? Because you wrote a bad text. So I was less than impressed by that particular teacher who wrote a bad book. All right then. Any questions before I get started? All right. So first what I'm going to do is I'm going to try and explain what mind-brain identity theory is saying exactly. Mind, and you guys know what mind means, right? All that stuff Descartes talked about, volition. Right, volition, ideation, hope, fear, dread, creeping horror, any kind of mental activity, right? Your mind is a stream of ideas. You have a stream of ideas, right? Have you ever been like half asleep and felt your brain going sort of weird? And these ideas, the way ideas follow each other, makes no logical sense. No, is that just me? So when you're half asleep, no, I'm the only. You sure? Okay, good. So I'm not as weird as I thought I was. Right? And you had to make an effort to make things go logical, right? And you both are aspects of mind, both count as thinking. And there's the idea, by the way, consciousness and mind are different. Consciousness is a different thing from mind. Consciousness is an aspect of mind. So, oh my God, this is a great example. I never thought of this, using this before. Because, listen, you have your stream of consciousness, right? You have your stream of ideas. And I've had this happen. Be having a stream of ideas, and some ideas will come through, and I'll react to them and go, wait, that's not right. I have this emotional thing, or this sort of gut reaction. It's not put into words, because the words are the weird thing. Right? You found yourself saying something dumb or something weird to yourself, hopefully not in public, not out loud. And then you make an effort, you make a mental effort to think correctly. Have you ever gotten a grip on your own thoughts? Made a mental effort, a volition to change what you think? There were, just after I first got divorced from my wife, my ex-wife, I picked my daughter up on weekends, and I found myself yelling at her. This was like 10 years ago, I'm still embarrassed about it. I find myself getting really, really angry at her for things that were really, really trivial. And the first time it's like, I find myself thinking, no, you said this, and that justifies my anger. And then I found myself looking at myself, looking at the way I thought, and go, no, that was out of proportion. So I apologized and said I'm going to try not to do it again. And then I did it again, but not as badly, and I apologized again and said we'll work on it. And the next time, I found myself having the thought to get angry at Eris for something like that. Because I was really angry at my ex-wife. That's what it was underneath. But I couldn't yell at her. I was afraid of her. And she's smaller than me too, so I don't understand this, but I'm a coward. So I got a grip, and I changed the way my mind worked, because part of my mind looked at another part of my mind and said, that ain't right, do it differently. And so all of this conscious thought, unconscious mental processing, where you recognize that something you're thinking consciously or doing or saying isn't what you really want, and you get a grip on it, or not. Some people go, rationalize and stuff. People go into denial. All those things, right? That's part of mind. And the mind-brain identity theory says that mind, all that stuff, is an effect of neural activity in the brain. It's effect of neural activity in the brain. And the brain is an organ. It's composed of neurons, glial cells, glands, and connective tissue, blood vessels. It's a big, complicated thing. And when I say complicated, I am not kidding. You have billions of neurons in your brain, billions of these microscopic cells that connect, each one of which connects to thousands of other cells. Each neuron takes inputs from thousands of other neurons and gives output to thousands of other neurons. It has been estimated that the number of possible circuits in the human brain, which means you think of a signal starting with one neuron, going to another 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 neuron, and then coming back to the original neuron, so that it goes around and comes back. They call that a circuit. The number of possible circuits in the human brain, considering all these variations, is actually larger than the number of particles in the observed universe. And when I'm talking about particles, I'm talking about protons. So it's a freaking huge number. The level of complexity in your brain is bigger than the level of complexity of all economic activity on the world and the planet. It's more complicated than the internet, including every operation of every computer on the planet. Right? It's freaking complicated. And it's highly, highly structured. So this insanely complicated organ that you carry around between your ears makes your mind. It operates, it does stuff, and your mind happens. So you think of like a television set. Do they still have those? Right, signals come in, they're processed through, now it's processed through, what do they call them, transistors, to integrated circuits, and that other things, and it produces pictures, right? Your stuff comes into your brain, what's already in there keeps working, and stuff comes out that you experience as thoughts, volitions, images, memories, all that stuff, any kind of mental thing, imagination, drunken hallucinations, whatever that goes on in your head, that's the result of neural activity in the brain. It doesn't say that the brain is the same exact thing as the mind. It doesn't say that, well, it doesn't say that any particular neuron is a thought, right? Mind is something done by brain. Mind is not brain. So already the term mind-brain identity theory is misleading. It's not saying the brain is identical to the mind. So you might want to add the word activity, mind, brain activity, identity theory. Nor does it say that a thought is the same exact thing as a brain event. Not really. Think about the thought. Okay, well, I was, yes, Stephanie.
I thought that's what it was saying. That the example that they were saying about the star in the book, it was saying that if the mind is thinking...
That's part of Schapa's objection. Schapa says that if two things are identical, then whatever you can say about one thing, you ought to be able to say about the other.
Okay.
Right? And I'm going to get into that. I promise I'm going to get into that.
Because I understood that more than I understood what exactly the mind-brain activity was. It just made kind of more sense.
Yeah,
to me.
well, that's because Palmer wrote a bad book.
Oh, okay.
Right? Because Palmer needed that's why I had the supplemental reading, because the stuff Palmer leaves out that is actually important. And one of the things that's left out is what the mind-brain theory is saying exactly. Now, here's the difference. Think about a spinning rock, and a humongous spinning rock, bigger than the moon, flying through space in an orbit around the sun that is closer to the sun than our orbit. Think about that. Think about this rock having, I think, a thin atmosphere that won't hold heat, that it's really cold, and there's, I don't know, 5 minutes. I haven't looked up. Is Venus hot or cold? Does anybody know?
It's pretty hot.
It's pretty hot. Okay, so it's really hot. Really, you know, it's hot. And like, when you think about this spinning rock flying around the sun, how many people have seen that rock with their own eyes?
A few. Venus.
Who?
Venus. Well, people have seen Venus.
How many people have seen that rock? The big thing, bigger than the moon? Does it look like that to you when you see it? How many of you have experienced that atmosphere? How many of you have felt that heat? How many of you have stamped on Venus or punched it with your fist to feel the solidity? Have seen the little rocks on the surface? Nobody has. Right? Nobody has. When people first saw what we now believe to be a big rock, what did they think it was? Actually, make it an easier question. What did they see? Yeah, I look up at the sky a lot, and I see Venus pretty frequently. What do I see?
A bright light in the sky.
A bright light in the sky, yes. I see a bright light in the sky, and if I pay attention and I mark out the positions of other lights in the sky, I notice this one moves relative to them over time. Okay? Before Galileo, did any human being look up at the sky, point at what we now call Venus, point at Venus and say, look at that big rock. That's bigger than the moon. And it's moving really fast in a nearly circular orbit around the sun. And it's closer to the sun than we are.
Yeah.
Nobody ever said that. Nobody ever had that experience. When they first decided that Venus was a ball of rock, had anyone seen even pictures of this ball of rock? In fact, they didn't even know it was rock. When they said Venus is a planet, is a body like the Earth, like the moon, that was a theory. And it actually still is a theory, although it's a theory that we are much more convinced of than we were. By the way, is an electron a theory or an experience? Is it something we believe in or something that happens to us?
Happens.
It's a theory. Right. There are things that happen, right? We get light coming out of these boxes in the ceiling. And during the day, we get light coming out of the sky. Well, we get light out of these boxes. I got a picture of me. Oh, I don't look good. I have a picture of me there that's sort of jumping around and waving his hands in a very embarrassing manner. And right, and how do I explain that? Well, part of my explanation is there's electrons moving through things, and they're making it emit photons, and photons are bouncing off me, and some of them are going into the lens here, and there's a charge coupled device in there that converts photons into electrical impulses, and it makes that picture, and it's storing stuff. Hopefully it's storing images that it's making, and it's making magnetism too. It's making magnetic changes in this thing called a hard drive, which I don't understand, but I know it's magnetic storage, and so on. It's doing all the stuff. These electrons are moving around. They're making my computer work. They're also holding my atoms together, as a matter of fact. If I lost all my electrons right now, I'd just sort of turn into, well, you'd all die because my neutrons would come out. And, oh no, well, the photon, I'd turn into neutronium and go down into the center of the Earth. That's what would happen. I'd sort of turn like into this gray goop, and boom, there'd be a hole in the floor, and it'd go right to the center of the Earth, and then eventually the Earth would collapse because of my neutrons. I don't know if that would happen. Maybe I'd make a black hole, but it would probably, the neutron would probably evaporate. If it evaporated, you'd all be dead. Yes, so hopefully I'll hold on to my electrons. Yes?
So what are you getting at?
Okay, well, I'm saying that thought is brain activity in the way, I just made up a new word, in the way the morning star is rocky planet Venus, or water is H2O. And take a glass of water, by the way. You take a glass of water. Think of the last glass of water you had. Did you look at it and say, oh my God, there's hydrogen in there, it's explosive. We could all die, the Hindenburg, oh, the humanity. How many of you have ever been worried about the hydrogen you saw in a glass of water? Never. Did you ever look in a glass of water and say, oh look, there's oxygen there, I can use that to breathe? Hey, someone got my chocolate in my, got oxygen in my hydrogen. Oh, it's tasty. You know, right? Why do we think water is H2O? I never see hydrogen in it. I never see oxygen. Look, there's some water over there. I don't see hydrogen or oxygen. I'm not even sure what hydrogen and oxygen look like. But I know what water looks like. Why do we think water is H2O? Why do scientists think water is H2O? It's their theory to explain the properties of water. Right? There are things you can do to water that create situations that are best explained by saying, hey, we've got hydrogen and oxygen. Does anyone know the best way to verify that water is H2O? No, that just makes water vapor. But it's close. Something else you do with something I mentioned before? Say again? That just makes water vapor. The water will freeze and then sublimate. Do you guys ever heard of it? Electrolysis? I mean, I knew this was... Oh, never mind. You guys ever heard of electrolysis? Oh man, you can do this. Get a battery, or if you're really brave, mains current, and you can actually do this at home if you have a good battery and stuff. You don't want to use too much electricity because you don't want to die. But if I get a battery, maybe a car battery, no, that's too much. I get like a 12-volt battery, a big old battery, and I attach a wire to one side and a wire to the other side, and I take these wires and I take like tumblers, glasses, or any kind of vessel, and I put these things upside down in water. Actually, I put them in water the right way up so they fill with water, and then you turn them upside down inside the water and then raise them. You've got to have some way of holding them up. So you've got these two things, right? If you take those two bare wires that are hooked to a battery, and you put a little salt or something in the water to make it conduct electricity, some kind of electrolyte in there, and you put these wires in under the okay, good, I didn't use the wrong finger. That'll be great, wouldn't it? In the video, we go. Okay, so you got these two glasses. Right, there's your water, and you've got your wires coming in, and I make one red and one purple, one green. right? There's a little bit of bare wire at the end, right, because you strip the cable. Okay, so you hook this up to a cell, and what'll happen for scientific reasons, for chemical reasons, because of the way chemistry works, is you'll get little bubbles here, depending on how much current you put through and how well you rig the electrolyte. And eventually you'll have a little pocket of gas up here and a little pocket of gas up there. If you do this at home, it'll probably take a long time to get any noticeable gas at all. So it gets to be kind of a boring experiment. But the cool thing is, one of these gases will be oxygen and the other will be hydrogen, in theory. Because oxygen is H2O, and what you're doing is, over here, on one side you're pumping in electrons, and on the other side you're pulling out electrons. And where the electrons come in, they go and they break out one of the atoms and make an ion of the other atom, and then they go down and they're attracted to the other wire, and when they get here, it goes the other way. That electron is stripped off. So I'm not sure which one it is, but let's say it's the oxygen. It pumps an electron into the oxygen lets go of the hydrogen. Let's say that happens over here with the red. The oxygen lets go of the hydrogen atoms are now a gas, and they start accumulating on the surface of the wire, and your oxygen is now a negatively charged ion, and that is attracted to the positive charge on the other side, and it goes and it moves over here, and when it gets there, the electron leaves the oxygen atom, and it's like, oh, where's my electron? No, I'm a gas! And the oxygen accumulates here, and then it bubbles up. So, you know, on one side you'll have a flammable gas that you can put in an airship and recreate the Hindenburg disaster, and then the other one is stuff you can breathe. And so, you know, if you have a mouse you don't like, who smokes, well, actually, you know, if you put a mouse into each of these, it'll swim to the top and try to breathe, and in the oxygen one, it'll survive. It'll get giddy because there's more oxygen there. It's pure oxygen. And then the other one will die because you can't breathe hydrogen. Yes, Stephanie.
So so what you're kind of getting at is that it's a theory.
Yeah, it's a theory.
Okay, so
what's our theory for how the brain works, for how the mind works?
yeah, because you completely lost me about the whole battery thing, and
Oh, well, okay. Well, you don't. This won't be on the test. I'm not going to ask you about electrolysis on the test. Let me go back here.
okay, thank you.
All right. In science, the dominant theory about where the mind comes from is that it's made by the brain. Our dominant theory for why we see the morning star is that there's a rocky planet out there. We have this experience of seeing the morning star. We have this experience of interacting with water. We have this experience of thinking. The explanation for seeing the morning star is there's a rocky planet out there. We believe there's a planet out there. You look up and you don't say, oh, I see this massive thing bigger than the moon. No, what you say is, I see this little light, and because I've read up on astronomy or someone else has told me, I believe there's a planet out there reflecting light from the sun. Take water. I don't know, whatever we do with water, we mix a little bit in scotch, only a little. and or whatever, right? You drink a glass of water, and you don't say, there's hydrogen and oxygen coursing into my body. You say, I'm drinking water. But our explanation for the properties of water, our explanation for that property I just erased, and the other properties of water, is based entirely on our understanding of chemistry, our understanding of how two hydrogen atoms get together with an oxygen atom to produce a weakly bipolar tetrahedral molecule. Right? It produces a particular water. You know why water is wet? I know everyone knows water is wet. If you get water on you, you get wet. But why? Why does water wet? What's wetness? Why does wetness come from? It's because of the characteristics of the water, the physical characteristics of the water molecule. It has two positive poles and weakly positive poles and two weakly negative poles, and they kind of stick together. And water is liquid because it's warm, and so warm that they keep pulling apart. They don't. What happens when the water is not warm enough? It doesn't have enough energy that the molecules can bounce apart, where the positive and negative poles are strong enough that they can overcome the weak tendency for the water to bounce. What does water become when it loses energy? It starts with I, ends with S. Ice. Right? Why does water expand when it freezes? Nothing else does that. It's because of those tetrahedral molecules, because they can only fit together that way. Water organizes itself as it. So there's all these properties of water, and they're all explained by water being H2O. But we never see H or O. We never look at water and say, hey, look, there's twice as many hydrogen atoms in there. Right, in a glass of water there. I know for certain, I know by a theory, the theory is there's twice as many hydrogen atoms in there as there are oxygen atoms. Do you believe me? Well, if you have the same theory of water as I do, you will believe me, because H2O. 2 hydrogen to 1 oxygen. So, my brain identity theory doesn't say that a thought is a brain event the way rocky planet Venus is rocky planet Venus. It says a thought is brain activity the way the morning star is rocky planet Venus, or water is H2O. Mind is explained by brain activity. The morning star, the experience of seeing the morning star, is explained by this theoretical entity, the rocky planet Venus. The properties of water are explained by this theoretical entity, the H2O molecule, and it's enormous amounts of theory in there. So, if I'm going to say something about the morning star, am I talking specifically about rocky planet Venus? Let me talk about the morning star, right? What do you see? When you say I'm seeing the morning star, what are you actually experiencing? What is coming in? What is the sense data?
Bright light.
The bright light in the sky that in the morning rises because we're turning towards it. In the evening sets in the west as we're turning. Which direction do we see the morning star? The sun rises in the east, so everything rises in the east. Right. Sun sets in the west because everything sets in the west because we're turning that way. Right. See the evening star in the west and the morning star in the east. We never see. Do we ever see them in the sky together?
What?
Do you ever see them at the same time? No, you don't. You can't. They're the same thing at different times of the day. no one person can see the evening star at the same time he's seeing the morning star. That is physically impossible. So that's what we're saying, right? We're saying the mind event, me realizing I forgot my lunch, let's say. Well, last week I forgot my coffee. And as I'm driving out on the freeway, I go, oh crap, I forgot my coffee. There was a brain event. There was a mental event, right? You ever had those kind of mental events? And usually there's like a little bit of sinking feeling, an impulse to curse or something like that. Right? So it's that. How do we explain that mental event? According to my brain identity theory, we explain that mental event by saying that is your experience of something that happened in your brain. Your brain did something, and this is how that thing felt to you. Have you ever put your hand near a power transformer? Like a transformer in a VCR or a powerful device. I used to, a long time ago, I worked in a company that made multiple cassette players for providing music. And every so often, my hand would go near an active transformer. And what happens is that my hand feels, and I'm like, what's that? Well, found out later, the way a power transformer works is by rapidly alternating magnetic fields. That's how electronic induction works. It's change of direction that works. You can't do a transformer with direct current. So what material in my body is affected, is magnetic, is affected by magnetism?
Your brain.
Say again?
Your brain.
Well, no, what material? Because I'm not... Right.
Your,
Iron, yes! I have iron in my blood. And iron is susceptible to magnetic fields. And there's a magnetic field going... And so if I put my hand near a power transformer, every molecule of iron in my blood goes back and forth very rapidly, and it feels really weird. So, I just thought of something. Okay, so you put power transformers under a seat, right, a wooden seat, and have someone come over and, wait until they're sitting, they're sitting quietly, calmly and unsuspecting, and then you turn the power on to the transformers, and so every iron molecule in their butt will go back and forth very rapidly. No, okay, I guess I have a weird sense of humor. I would totally do that. Yes. You could work that into all kinds of jokes. Right, so, the mind-brain identity theory says thought is brain activity in the way the morning star is the rocky planet Venus, the way water is H2O. We explain thought by pointing to brain activity. Arguments for mind-brain identity theory. There's a fellow called Smart mentioned in the text. Is it JCC Smart? Or, yeah, okay, good. I always get that wrong. JCC Smart. So argument number one, JCC Smart. I don't see why mind wouldn't be physical. And the argument is basically, well, everything else is physics. Everything else is a physical system. Why not the mind? Yes?
Okay, so I understood what you were saying before, but I really wanted to argue
Sure.
what you were saying. I
Okay.
just don't know how to explain it.
You've got two options.
Okay.
And you can take both options. One, you can argue now, and we'll discuss it.
Okay.
Or you could put this into a paper. If you haven't done all your Odyssey stages yet, you could do it as an Odyssey stage, and that way you'll be able to explain everything in detail, and you have a lot of time to think out what you're saying. And I won't cut you off to say, "I'm sorry, we've got to move on."
Okay.
Okay, go. But go. Say something.
I forgot now. Just keep going.
Ah!
You ruined it.
I ruined it. Oh God. But,
I'll just finish everything and then I'll argue later.
okay, finish everything and argue. Right. So, JCC Smart says, yeah, everything's physical. I don't see why the mind should be left out of this picture. And this argument was made in like 1966. It's like a 40-year-old argument. And it's okay. I actually think it's kind of like, if you think about it, yeah, sure. But it's not everything we can say. So argument number 2. Well, actually, I'll call them A and B, because I'm going to do numbers here. So argument A, argument B. Right? For every observed mental activity, mind-brain, neurology, and endocrinology. Endocrinology is the hormone one, right? Is that right? Endocrinology, hormones. I'll put a question mark there. Hormonology, right? Physiology. Any brain activity, any mental event that anyone's ever observed, and I'm not talking about imaginary mental events, I'm talking actual observed mental events, can be explained by this theory. We can come up with an adequate explanation for it based on mind-brain identity theory. Many mental events have been proved to be correlated with brain events. And what I mean by this is, you know how sometimes people get angry when you criticize someone they admire? Like if someone's a big fan of Barack Obama and someone starts talking about extrajudicial assassination of American citizens by drone strikes, and they get like all angry and like say, do you want the terrorists to kill us all, or something like that? Have you ever had someone blow up on you just because you criticized them? You made a reasonable comment and then they said something stupid and then they got like, haha, I showed you, you're stupid. Right?
Yeah.
There's nothing more annoying than being called stupid by a stupid person. It's, you know, I don't mind being called stupid when I am stupid, but that never actually happens. Smart people never call me stupid, no matter how stupid I am at the time. But here's the deal, right? There's this behavior, and my friend Daryl does it has done it a few times in front of me. And there's this behavior where people get angry and defensive, and they engage in irrational verbal behavior, and then they have this sort of this feeling of triumph, where they're like happy. I showed you. This fellow called, I think, Douglas Weston. His name is Weston, and he put people into an fMRI, a functional magnetic resonance imaging device, and watch what happened in their brains when they did this. And stuff happened in their brains when they did this. Right? So what happens is first, you know, the limbic system starts up. This is a system that has been proved to be associated with arousal, fight, flight, emission of adrenaline. That starts up, and then the language center starts going. And while this is going on, and then afterwards, the pleasure center kicks in. There's a spike of pleasure. And through this process, the dorsolateral prefrontal cortex, this bit on your brain that's sort of just in front of just behind the frontal lobe, that's called, I think it's just behind the frontal lobe, dorsolateral, it's on both sides and the top. It's stone cold. There's no activity there. The part of the brain that does rational thought is not working. Have you ever noticed your brain shut off, your mind shut, your rational portion of your mind shut off when you're angry? And then when you calm down, it starts working again, and you go, oh my God, what did I just say? In fact, I think that's what happened when I was ballyragging my daughter for no good reason. So that's correlated. That part of the brain works when this happens. Everything where we've been able to check the brain for activity or function, we found a correlation. They identified, and you know how they do brain research like that? They wait until someone has brain surgery and they ask them very, very nicely, can we poke around with your brain while the top of your head has been cut off so you can have brain surgery? Surprisingly, many people say yes. Sure, knock yourself out. How about, have a good look around in my brain. Just make sure you put the top of my skull back on when you're finished. Right? And leave everything where you found it. I don't want to find my amygdala under my cerebellum. Don't mess anything up. That would be really weird. I'm going to reorganize your brain in here. So that's just not good. But they do that and they find these correlations. They found a neuron. With one guy, they found a neuron that could distinguish between a line that's straight up and down and a line that's tilted to the left. Or the right. I'm not sure which one it was. But a neuron, if you showed them a line like that, it wouldn't fire. Showed them a line like this, it would fire. And that's the only circumstances under which it would fire. That's the only stimulus it would accept. Which is actually really cool when you think about it. So we know how the brain works to make mental events, in a sense, and we have tons and tons of evidence. And there's another brain damage. You've heard the phrase brain damage. This person's brain damaged. What does that mean? Right? What does that mean? How does that pan out in your life? If you say you're going to meet someone and you're going to deal with this someone, but I warn you, he has sustained brain damage. What do you expect? Well, okay, being a tweaker is associated with brain damage because tweaking rots the dorsolateral prefrontal cortex, but it enhances ego, and I think arousal too. Right, and I had a fellow explain this one. I got into an argument with a tweaker, like out of nowhere, and she's yelling at me, and like, what the hell just happened? This fellow says, oh, she's a tweaker. Because tweaking, the meth, degrades the part of the brain associated with rational thought, but it enhances ego. And so I said to them, oh, so it makes them into Republicans. It's more true than you think. Yeah. And so, I've met Democrats like that too. But, right, says, someone's a tweaker, are you expecting to have a rational conversation with them? If you know someone has brain damage, you know that there'll be something they don't get, they'll be difficult to communicate with, they might still be perfectly nice people, but there'll be a deficit, something to deal with. Right. And there are particular kinds of brain damage that are associated with particular kinds of deficit or change. You guys ever hear of Phineas Gage? Did I mention him? Okay, right. The tamping rod through the head. He didn't lose any mental faculties, but his personality changed. Right? Your personality is part of how your mind is structured. How you react to things, what you find interesting, what you find boring, what you are likely to say in any given situation. Yes, there you go.
I was going to ask about that.
Yeah, okay.
I was thinking about it, like, would his personality change because, like, a certain part of his brain was gone so he could only be angry? Or was he just pissed off that he got hit in the head?
I think it was the second thing. That, right, it's a complicated thing. He kind of turned mean and irritable. Part of it is subscribable to pain. I mean, he was never completely whole after this. He had a fairly miserable life after the accident. But at least part of it is that, it destroyed quite a bit of his brain. Now, the brain has also been shown to be able to grow back certain functions. If someone has a stroke or has damage to one side of the brain, that they lose function. They do this thing with war vets now who have injuries. So say if you're in Afghan and you get a head injury so that suddenly you can't use your right arm anymore. The rehab therapy is they'll take your left hand and they'll tie it behind your back and they'll tell you to pick stuff up with your right hand and do it. And at first you're like, you fucker, you bastard. No, try. Come on, try. Okay, pick up that paper with this hand. You're like, oh. And after a while, if you keep trying, that makes neurons grow. It makes axons and dendrites reach out to each other and make synapses. And suddenly, the part of your brain that used to control your right arm is gone. I think it's over here. I have no idea, really. I think it's kind of over here. Let's pretend it's over here. That's gone, it's destroyed, but a bit of the brain next to it starts growing and takes over that function and hooks up to those neurons. And after a while, you can sort of like...
My platoon sergeant had that problem.
Say again?
I was in the Army, but my platoon sergeant had that problem.
Okay.
He could still move his a little bit, so it took him forever to be able to do that.
So do you think so I would explain that by saying his brain grew back. A bit of his brain was moving, was missing, and then they invaded. Neurology today is very exciting. It was always pretty exciting, but it's just gotten amazing. So if you want to read up on neuroscience, read Oliver Sacks and a lot of later guys too about how the brain works and what you can do with it. It's incredible stuff. nothing, no mental activity has ever been proved to be independent of brain events, and this is an important thing. There's no thought anyone can have that doesn't produce a brain event, that doesn't produce brain activity. Whenever we've been able to observe the brain while someone is thinking, unless it's like a very mild thing, there's a change in the brain when the thought comes along. There's activity in one area and not in another. Right? And in fact, one of the criteria for death is cessation of activity in the brain. We have this phrase, brain dead. The brain is no longer doing anything. We take that to mean the person is dead. And there's some complications there, but that's basically what it is. So many mental events have been proved to be correlated with brain events. None have been proved to be independent of brain events, to be uncorrelated. Brain is very complicated. We don't know everything about it, and we can't really observe it very closely even now. So, and the third premise here. The main competitor for mind-brain identity theory is dualism, that there's an immaterial substance. You can come up with all kinds of alternative theories, but none of them are any really serious. And this is the only one that comes really close to being serious. But let's say, maybe there's some other theories that I don't know about. No other theory. No other theory explains differences in brain activity or mental capacity at all. You guys ever heard of aphasia? Aphasia is a difficulty or inability to handle certain aspects of language. There are people who have difficulty, roughly speaking, there are people who have difficulty that's roughly correlated to difficulty with syntax. Crudely, they can't figure out meaning from word order. They have trouble with that. And then there are people who have trouble figuring out the meanings of words, or retaining the meanings of words. Right? And it's not exactly that. It's actually a bit more complicated than that. But there's sort of syntactic trouble and semantic trouble. And there are these two areas that are usually on the left side of the brain. This is why I point here, because this is where I think my areas are. There's something called Broca's area and Wernicke's area. And if you have damage to Broca's area, you get what's called Broca's aphasia, which has various symptoms associated with one kind of language difficulty. And if you have damage to the other one, you get Wernicke's aphasia. Right? And every time they've had someone with this kind of damage, with this kind of mental problem, with this mental defect or inability or difficulty, and they've been able to check the relevant areas of the brain, which are sometimes on this side and sometimes on this side, usually on this side. They found damage there. There's a lesion, there's damage, there's a problem with it. So, and that's the explanation. Why do you have trouble with semantics? Why do you have trouble with syntax, with getting meaning out of word order? Oh, well, look, there's this little bit of your brain is damaged. There's this thing that correlates to it, and there's always associated with it. And we say, look, our explanation is this part of your brain is involved with processing language, and when it's working right, you do semantics right. And when it's working wrong, you do semantics badly. Ask René Descartes how he explains that. Cartesian dualism, we have an immaterial mind. What is it about the immaterial minds of a person with aphasia that's different from the immaterial mind of a person without aphasia? What can you tell us, Mr. Descartes, about these two immaterial minds? The one that can handle semantics perfectly or properly or in a normal way, and the one that has an abnormal difficulty with semantics. What's the theory here? How does the theory explain it? And there's no answer. There's nothing anyone can do. And there's no medicine possible based on that theory. One of the things about mind-brain identity theory, the mind-brain theory, is that we can do things with the brain to improve and preserve function. Now, it's not properly understood, but if your brain is properly nourished, your brain is better. Well, here's the thing, and future parents, one thing you can do for your kids when they're very, very, very young, a good thing to do is to sit and read to them from the very beginning. Babies who are read to have more synapses than babies who are not read to. So the brain grows and structures itself in response to input. You're not born seeing the way you see now. There's this thing called neurodarwinism that operates in the striate cortex, that your brain learns how to organize the visual field after you're born. While the brain is growing, it organizes itself in a certain way. Some synapses are made, others are destroyed, and you learn to see. You learn to create a visual field. Cartesian dualism cannot explain that, and it cannot help you make your children smarter. Children who are read to are more likely to read. Children who read are more likely to do well in school and to do well in life. And so that's something you could do as parents to give your kids a leg up or level the playing field. So when my daughter was young, I would read Nietzsche to her. It had no effect on her political or philosophical beliefs. But she's very smart. She's studying linguistics at UCLA. So we have all the evidence in the world. There is no competing theory. Oh, I'm just going to write this here in little letters for Occam's razor. If you can't see that, it says Occam's razor. Occam's razor is necessary for this argument. And the conclusion of this argument is that mind-brain identity theory is true. Now, there's various ways of phrasing the argument. You can organize it differently, but it's basically that it's an adequate explanation. It explains absolutely every phenomenon. All the evidence we have supports it. No evidence opposes it. And there is absolutely no evidence for any competing theory. In fact, the competing theory, the major competing theory, does not perform at all. I mean, remember Copernicus versus Ptolemy? Ptolemy could make predictions, Copernicus could make predictions. You could do stuff with both theories. You could tell, right? What if we had Copernicus versus the angel theory? Why are the lights moving around? Well, this angel, they're angels. They're moving the planets around. They're moving the little lights around, and the little torchieres or things, flashlights. Or they're giant fireflies, right? They've got these huge butts that glow. Anyway, so so sometimes they move this way and sometimes they move that way. Why? Oh, they just feel like it. How are they going to move next? I don't know. I don't know when they're going to feel like it. With Ptolemy, yeah, I can tell when they're going to move back and forth. I've got a theory. I can make predictions. We can check them. Copernicus, I can make a theory. Predictions. Kepler, I can make predictions. But the angels do it? What prediction can you make over that? So, this is the idea that mind-brain identity theory is true. Right, so this is the evidence and argument for it. It's all the evidence. And I want to point out, I'm not sure what to make of this, but it's kind of weird that the book doesn't talk about this. Instead, it goes back like 40 years to J.C.C. Smart, and all he says is, all he's quoted to say is, I don't see why mind wouldn't be physical. Is that all he said about it? That's kind of a weak argument, isn't it? Why would Palmer give a weak argument for mind-brain identity theory when there's an enormously strong one available to him? I don't really understand that. Anyway, any questions about the argument for mind-brain identity theory? All right then, let's take a break, and I'm back in 15 minutes, back at 8:15.